those in the US and good afternoon to those in the UK. Welcome back to the BTK Technical Conference after a 2-week break. Today we'll have one presentation, which is about the Data Discovery Index. We're scheduled to start at 8 a.m. Pacific time and end at the latest 9 Pacific time. These conferences are recorded and will be accessible online after we process them. If you have any questions during the presentation, please type it in the message box providing the application. And also, please mute your mic during the presentation to prevent any background noise. So today, Yasset from EBI will be presenting about the Data Discovery Index, or also known as the EMBL-EBI, which aims to provide dataset discovery across a heterogeneous distributed group of genomic, proteomic, and metabolomic data resources that is data publicly in 2 dimensions and 6 dimensions. Now, allow me to introduce you.
Well, first of all, thank you, Vincent, for this introduction, and thank you to all of you to be here on this short presentation. And we also will do a quick demo about this tool. Also, I think, well, this is the first time we met all together in person, and we have here the team from the EMBL and also from UPLL. Finding a publication nowadays is
Hi, Yasset, we're having trouble hearing your audio. It's cutting out a lot.
Now it's fine. I don't know if we have some noise. Is that okay right now, or?
That sounded a little bit better.
I think everybody who's not speaking should mute.
Okay. Let's try now. Okay. Okay, do you hear me now?
Yes, that sounds much better.
Yeah, now it's better. Okay. Well, is the process of finding a publication nowadays is very straightforward, let's say. I mean, if you are interested in a publication, you basically go to PubMed or EuroPubMed Central to find what what you're interested for, and then get the summary of the publication, the author of the publication, the titles, and most of the researchers, the first thing they do when they are interested in some topic is go in there. But finding a data sets can be a really difficult task. Not because the data is not there, it's because it's difficult to find this data. And there is different approaches. For example, one of them can be go to the original publication, find a publication in PubMed, and then, for example, in the last 2 years, we suggest to the author to put the PX ID in the abstract of the publication. Then you can go to the original repository and find this data set. Another way of retrieving interesting data sets or finding different interesting data sets is going to different resources like Protein Exchange or Protein Central and find from using different keywords, or going, for example, to Metabolome Exchange. But so far, still those resources are not so, let's say, well established in the community, and then you need to most of the people, they still find some data sets going to Google and then type what they're interested in for, and then directly find those data sets. Especially because those systems are well designed for, let's say, Metabolome Exchange for metabolomics data, Protein Exchange for proteomics data, and so on. one big question we want to address is if data sets is nowadays relevant beyond the publications. And there is a small trend we found that in the last couple of 3 years, let's say, most of there is an uncommon trend of creating new journals or new type of publication that are extremely focused or they are focused on data sets. This is the case, for example, in proteomics dataset brief created in 2006, but GigaScience in 2013, data in brief, and very recently scientific data was created for providing information around the dataset itself. I mean, how about not only about the biological claims or the results, but also the dataset, the protocol related with this dataset, the information in those dataset, and a way also to promote that. In that content, we are trying to develop a system that have 3 main aims. The first aim is to provide a data discovery index for omics datasets, let's say genomics, proteomics, and metabolomics from the very beginning. Integrate databases and repositories from US and Europe in one place, and provide the infrastructure to add new databases and repositories for searching, navigate, and find high quality and interesting data set very easily. And we have been working in these 3 months as part of the BD2K project to release a platform and infrastructure that provide a simple way to plug databases and the database information and index this database and make available this data to the end users, and then where the users can find the interesting data set and they can go to the repositories and download this data and analyze this data. This is the basic picture of the architecture that we developed. In the first part, we have the database, original databases, let's say Pride, Peptide Atlas for proteomics, or Metabolize and Metabolo Workbench for metabolomics. We export this data to so-called DDI XML, a highly customizable XML that can add features about the every data set, and then we import those XML inside the EBI search indexer, which is a system to index using Lucene the information from different resources. The good thing using the EBI search infrastructure is that also other databases like Ensemble, PubMed, Uniprot, or Campbell are also indexing in this system. It will enable us to find those datasets using biological evidence, let's say the protein IDs, let's say publication information from the abstract of the publication or Campbell structures. Then we implement our web service based on the EBI search indexer, and to manage all the logic related with the web app. And finally, we develop a web app to be able, a web application to be able to search and navigate and show the data to the end users. The XML, which is actually the key point or the most important, let's say, which contain all the data from the resources, has three different set of fields. The first field is, we call it mandatory fields. They are, for example, the repository ID, dataset title, publication, submitted information, and the original URL from the original resource. Then we have some so-called decided field, which are description, abstract, sample, protocol, data protocol, PubMed ID, if this dataset is related with a publication, organisms, tissues, disease, and so on. And we have also additional fields. And this is actually really important because, for example, in the additional field, we have the cross-reference to the biological entities in the dataset. Let's say we have a proteomics resource, a proteomics dataset, and this dataset identify or quantify a different set of protein. if we put also, we also allow the user to put in this XML the IDs of the protein, enable us to find those data set using information from the protein, for example, the pathway information, and so on, name of the protein, gene, and so on. We so far already have prime massive peptide address metabolites, metabolo workbench, EGA. I need to say something here. This is actually something that has been done by PubMed since the system was established. They are based in XML. Every journal gives an XML file to PubMed in an XML structure to retrieve the information and also to index this information. All of those XML, they go through the EBI search architecture, and they are indexed using Lucene, and we have already more than 520 gigabytes of information and more than 1 million entries. And because this information from datasets is also indexed with Ensemble and PubMed, the system is allow the user to find information using different sources. Not only the metadata that is inside the dataset. And then after the index, we have also the web service and the web application. I will try to do a quick demo. Let me switch to the application. This is actually the landing page of the application. What we aim in this landing page or the application, the home page, is to provide the user a way of searching the data, explore the data in different ways. For example, and we split this in different blocks. The first block is this one. It's on the top of the page. Is a search block, general search block, when the user can type a word and find data set related with this word that contain this word in the metadata. We have another block which is a word cloud, and this one is basically a way of accessing to the data set using different keywords that are the most frequently one in the data set. And we split this in three main categories. The first category is the description of the abstract, which is actually the abstract of the data set, the general description of the data set. The second one is the description related with the sample. The description related with the sample. If you click here, all the word cloud change, and then the words that appear in the word cloud are completely different because they are. This is information related with the sample. For example, in this case, trypsin is in proteomic. How this the sample was trained, if it was using trypsin, or the mass, or column, or even the mass spectrometer that was used. And then we have data, and then the data specify different words about how this data was trained, or how this data was analyzed. And for example, you have here more than 200 data sets that were analyzed or identified using Mascot, and then Mascot appear as a software that has been used quite a lot. Then you also can click one of the words and then do a search using this word. The second box is more related about the biological insights of the data, and then we have tissues, three main categories also: tissues, organisms, and disease. And the user can basically click one of the bubble of the chart and also do a quick search in the system. One of the other features that is as a side effect of this visualization technique we use is that the system, the boxes also give you a way of a statistic about the system. For example, if you click tissue, the size of the bubble also said about how many data set has been analyzed using this tissue, or in this tissue, a specific tissue. That's why, for example, when we click organisms, you will see that the organism that has more data set in the system is Homo sapiens. The other box is related with a pie chart related with the number of data set for every repository. In this case, we have PRI, for example, EGA, and all of the data set that the system right now contain. And also we have another category that we call omics, and split the concept taking into account the type of data that is contained in the system. Then in the second, the other boxes we have are, for example, latest data set, which is basically a way of finding new data set that has been published in the system, and also most accessible data set. Every time someone or a user click a data set, we basically trace that, and then this is a way also to, have a kind of ranking or a kind of showing to the user which are the most accessible data set, which are the most interesting one for those users that arrive to the system for the first time. The latest one is the number of data set by omics and the date of publication, and then you will see in 2015 how many data set the system had, 2014 and so on. At the end, we have, three boxes about the news, and then we have a Twitter account related with the system, the statistic about how many repository we have right now, how many data set, how many diseases, and how many tissues and species. And finally, an about box about the information on the help page about the system. Let's do a quick demo of the system. For example, if we type mitochondria, you can see basically that we have an autocomplete feature that suggests to the user the words, and the search page, which is actually the main feature of the system, follow an approach of, let's say, most of the search page, or a more popular one like Amazon and so on, that you have a central page when you list all the data set, and then you have a way of filtering or refine this search, starting from the categories that we are using right now, like proteomics, metabolomics, and genomics. The repositories that contain this data, for example, for this search, we have three repositories in massive, three data sets in massive, one in metabolites, one in metabolomic workbench, one in three metabolomic workbench, one in peptide atlas, and so on. And then you can refine this search using Facet by species, by tissues, by disease, by modification if it's in proteomics, by instrument, the type of instrument, by publication date, and by technology type. We use this technology type because it's also good to highlight that we merge different contexts and different repositories coming from proteomics, metabolomics, and genomics, as I said, and they use different way of controlling the metadata, and we create this technology type, for example, to have a kind of category between the type of MSMS experiment that was done, if it's SRM or MRM or button-up proteomics or chalk-up proteomics. Is a kind of classification inside the field. Let's say we click the proteomics repository. If the user click the proteomics dataset, the first one, what we will show is a page of the dataset, and then we will show to the user the title of the dataset, the abstract of the dataset. In some repositories it's called description, in others they call it abstract. We decide to call it abstract from now. Then we have the sample protocol, is all the metadata related with the sample, how the sample is analyzed and so on. And then we have the data protocol. In this case, is quite huge. Then we have the instrument, and the user can click from this instrument and do the search in the system. We have the organisms and the tissues, and actually we also provide the link to the original repository. If the user click the ID in the original repository, in this case PRI, they will go to PRI database. At the end, we also provide information about the publication. about the publication related with this data set. In this case, we try to do not provide too much information, only the title of the publication, the authors, and the abstract. And also we provide some kind of visualization artifact, which is in this case to give a relevance of the to try to talk about the relevance of the publication. In this case, the Almetri score. And at the end, we provide the list of the files. In the future, if the user wants to download the files from a specific dataset, they can do it using the DDI web service or the DDI web page without needs to go to the original repository. We also provide another box here, which is a similar dataset. And actually what it does is provide information about interesting datasets that are closer, taking into account the metadata to the original dataset that we are showing in this page. And it's basically also a way of finding new datasets if the user is analyzing or is interested in this original dataset. They can go to those datasets and see why they are so interesting or why they are similar to this one. I think so far is what I want to expose. Also, we have the API. All the API is documented, or we have help page. If we go to tools, DDI, web service, the web service provides entry point to retrieve the statistic, the information about one data set, the publication information on one particular data set, and all the functionalities. Which means that the web app is the first client for the web service, but in the future we can implement our client or different clients to interact with this with this resource. We also provide information about the databases that are already included in the system, like PRI, EGA, metabolites, and some kind of a statistic about how many data sets are included in the system for every database. I don't have much to say about it. We are now working in a way of linking different data sets. For that, we are trying to refine the way that we store the data, how we modulate the data, and also trying to come up with kind of ranking using the biological evidence, the proteins, and the metabolites. And I need to say, well, this is not only our work. My work also is the work from PRI team. The EBI search team has been very useful for us because all of the infrastructure of the backend is based on the EBI search infrastructure and the metabolites team and the EGA team. Thank you.
Okay, thank you, Yasset. Are there any questions?
Yes, it's Pepe here. Amazing tool. So this has been very helpful presentation. Since I have you, do I also have Henning on the call?
Henning?
Yeah, Henning is on the call. Might be muted.
Oh, I'm sorry. Oh, is he on the phone? Henning? Henning?
He is on. I'm not sure.
That's okay. We could just go through the slides again, if that's okay with you.
Okay, I'm there. I'm there. Can you hear me now?
Yes, we can.
Yeah.
Yes, wonderful. Hi, honey.
Okay.
So I
just
started to go through the
unmute
slides
myself.
again. Starting from the title slides, would you like to call it the omics DDI? So we change the title slides? Is that being modified on the website?
Pepe,
Uh-huh.
So I left for this, I left the original name because Mingze is the name of the grant proposal, which is still pending, so I didn't want to use that. So we have a bit of a Babylonic confusion of names, but I thought about this, and if it's okay for you, we can use that, but that's actually the name of the pending grant proposal.
Right. So,
While
Henning, since this is a slide we're going to use for future demo, I think you need to modify the slide title.
okay, so we replace everywhere the new name is Mingze. Is that the...
You could do that, or actually, Henning, after I've gone through all the materials sent to me, this is predominantly proteomics and metabolomics. There's some genomic data sets, but not a lot.
Actually, by now, the number is almost, I think EGA is now one of the larger contributors if you look at the statistics.
Okay,
But it's only one resource.
I see. We could definitely call it omics. That's very fair. But if we just call it data discovery, I think we're inviting criticism.
That's fine. So just let me know that, should we say omics discovery index?
That sounds good.
Okay, so we say everywhere consistently omics discovery index, not Mingze, because that's the name of the grant, but we avoid the criticism. Okay, Yasset, action item.
Do you want to call it omics investigation discovery index? Oh,
No.
no.
Sorry, but no, that sounds very sort of
Odd.
wooden.
Okay.
You can say omics data discovery index if you want.
This, in many slides, you already put in the BD2K logo, but the first slide, there's no BD2K logo. And the second slide, there's also missing BD2K logo, honey.
Okay. Yeah, I can do that. I can change.
Could you please? I think that's where NIH is going to be sensitive about.
Okay.
So just to be clear, you want it on every slide in the footer.
Okay.
If that's okay, unless you want to create a different presentation for the NIH demo.
No, it's fine. I just want to be sure. So we can put a consistent footer with all the contributors and BD2K. That's fine.
Okay.
Wonderful. And then on the backbone structure workflow slide.
Okay. This one?
This one right there. So you very nicely placed EBI search indexer there.
Yep.
So, Henning, the questions you will be for sure anticipating from one of the NIH people would be, what are the potentials of using another search engine?
I think that is already on one of the slides mentioned. It's definitely mentioned in the report I wrote for you.
Right.
And the statement is everything we are using is either open source, or in the case we use one commercial system which is scheduling the different jobs, but that is replaceable by any other scheduling system. So we have no dependency on any commercial systems, or no strong dependencies. So in principle, the system is portable, but it will require work. It uses currently EBI infrastructure. It will use A, quite beefy infrastructure, and B, it will require work to do the actual porting. I have discussed that already with Rodrigo Lopez, who is the responsible group leader for the actual operation of the indexer. And this would, that requires work. It's not just take it and run it somewhere else. It needs some doing.
Okay, that's quite fine. I just think we should be prepared to address that question. We could easily say we could build our own search engine for NIH, or we could just do what Brian has been doing, get it onto Google search engine. But it will take effort for integration.
No, that's something completely different. You can probably build a system on Google, but that's a completely different system.
Yeah. Henning, perhaps changing the EBI search indexer, we can put leucine search indexer, which is basically a system based on leucine. Doesn't matter where it's running right now.
No, because it is important. It is we advanced quickly because we based it on existing systems. Okay. We can move it elsewhere, but that requires work. We don't want to give the impression that it can just tomorrow run anywhere, because it's not true.
Okay, so Henning, if you would give estimates based on your experience and your knowledge in the field, would you say it requires work of 3 full-time programmers for 6 months, or could you give a rough estimated projection on the work scope?
I would say it would be definitely less than that. So I would say 12-person month is probably good enough, and that would be, if you then implement this with 2 times 6 or 1 times 12, but I think that is a realistic estimate for the actual porting of the system. Okay. But then again, it would need some kind of farm to run on, but the farm could be, let's say, based on Amazon Cloud or something like this.
Okay, so it's possible that it can be transduced into a parallel version that uses AWS and another house-built search engine?
No, it shouldn't use another house-built engine, because then we really start from scratch. All we want to do is we need to port the underlying infrastructure components. So really how to schedule the large indexing jobs on multiple machines. This part of the structure, this is what needs to be transferred. The actual, how the search engine works, if you say you want to use now the Amazon engine or so, you start from scratch, then it's a new project, which is perfectly fine, but it's another project.
So, Henning, I think this is probably a question that's going to come up. It's good that we're having very productive discussions.
Yeah, but that is, well, if you build a search engine on one system and then you say you build it on another, well, then it's a different thing. So really, why we have progressed quickly is because we have used something which is already there, and we did not start, which is there and is already fairly specialized to biology, and we did not start from, let's say, just Amazon or Google or so. We used already experience which is there, and we have also the confidence that the system will scale because it's already indexing all of EBI. So I think giving up all of this for the sake of giving it up, I don't quite see why. I understand perfectly the political motivation to run it somewhere else, but why change the architecture?
So even it's running somewhere else, Henning, that doesn't mean this one wouldn't be running. But I think you probably could perceive NIH would want to have a sister version running on a different platform.
Yes, I understand that, but the different platform would be really like, what's the different hardware infrastructure and how to schedule the work on that hardware infrastructure. I don't think it should change to use another search engine just for the sake of it. I think we are meaning the same thing. We are just not.
Can I ask a question?
Oh, yes.
Yes.
Oh, hi.
Henning, I assume what comes before and comes after the indexing engine at the EBI, you're willing to share, both the Lucene indices and the sort of the process XML?
Yes, so we are willing to share everything. I just said the only thing that is a dependency is the EBI infrastructure, meaning the cluster scheduling system. That's the most concrete one, LSF. We are willing to share everything, so there's nothing confidential. It's just that, yeah, changing from, let's say, Lucene to Google, then it's a new project.
No, but I guess my point is that if NIH, others, or us, or whatever, wanted to create another instance for political reasons, then we could just pick that up at the point at which you have the Lucene indices.
Yes. Of course, we can also just pick it up at the point where just the contributing databases generate their XML. I mean, you can
Right.
restart from wherever you want.
Right, and so I guess then the question comes back to Pepe. I mean, would that be enough of a opportunity for NIH or us or whoever else to rebrand as appropriate?
So the way, Andrew, you've raised the most important point. I think the pioneer work, the overall architect design, and the creation of a very effective and robust index system that Hanning's team has done, that part has been widely acknowledged at NIH. For everyone I've spoken to off the record, everyone said that. You now coming to the point, there is both the scientific element where something being created and even others to follow. This forever will be the very first omics indexing system in the world. So when everyone else follows, you take it as a compliment. Count on, even if we do not reproduce a sister version using either AWS or Google, someone else will. This is how I see things are moving. The acknowledgement and the credit to Hanning's group as the very first one, that's in the stone. That there's undisputable, that's not a question at all.
I think I'm still not seeing then the NIH's, what would the ideal situation be from the NIH perspective in your view?
We don't know, but we'll find out.
Okay. Well, look, I mean, as far as I'm concerned, right, I think Henning's statements about, anything and everything being open,
it's amazing.
I think would be well received by NIH.
Yes.
I think Henning's point about not reinventing the wheel as far as the indexing engine, I think should be, scientifically and technically should be, well recognized and accepted. And if nothing else, in my opinion, if they gave this and they said, no, you need to rethink this, I don't know. I would like to believe that, okay, fine, we would have the opportunity to rethink that without being immediately sort of branded as being, not playing nicely or something like that. So, my 2 cents.
What I will do is I will create a reserve slide for this, which is exactly addressing this point, what I think is necessary to port it to somewhere else. I have anticipated the question, that's why I already talked to Rodrigo. I will describe on there what I think would make sense to port it. If NIH decides they want to start from new, that's fine. One thing which you haven't discussed yet is part of the power and, let's say, the potential future for the future of this is that it interlocks with EBI, because as Yasset has briefly hinted at, we can easily bring in, let's say, a direct link not only from the data sets to the proteins to all the data objects at the EBI, because it's already in the same system. We haven't really exposed that yet, but this is definitely a direction we can go, but we can also leave it if that's politically desired. I mean, NIH is paying the bill, so we'll do what they say, provided we get the credit for what we actually do.
That's wonderful. So whatever you could do there, Hanning, that's going to be very helpful. And maybe for time's sake, we save some of the discussion of additional organization issues in the leadership committee call.
Okay.
Okay. Congratulations for amazing success advancement on this project.
Thank you.
Okay, are there any other questions?
So I have a question. So as long as we're on this slide here, right, this issue of going from databases to DDI XML, I guess I'm curious, you know, because you control many of the databases that we're talking about here. But I guess I'm wondering, you know, if there are other smaller data repositories and somebody wanted to write a parser into the DDI XML format, or if somebody, you know, thought a particular field wasn't particularly well represented. I don't know, to what degree are you confident that, you know, the first, I guess I'm hinting at the difference between centralized work in this regard versus distributed work, right? If somebody else wanted to contribute to this effort, is there any way possible that you want to enable that?
So as I see this, the concept is that there will be eventually a registry where any resource can register, hey, I am publishing data in the DDI XML format. And then the index and all that requires is something like a maintainer URL and then an FTP where to get the XML. And then we will probably have a manual validation step so that we don't pollute the data, the system with nonsense data. But then we can, this will then be picked up every night if it's new and will be indexed, and that's it. And there might be a distinction between, let's say, first-class and second-class citizens. We might decide not to index everything that's in the registry, but only a subset. But this is really quite a long way. But the plan is definitely to have this open so that even smaller repositories, and I'm thinking specifically on, for example, the data journals, if they're interested is a different question, but it would be great if they would be interested to expose their data sets through this. And they might have, let's say, only a few dozen papers or so, which are relevant, but this would fit in perfectly here if they just produce this XML, register themselves, and we pick it up.
Just to add a few lines, as Henning said, also the XML right now is extremely open, let's say. I mean, we have already in place some cases like Massive, which is actually, as you said, one of the databases that you said we control it, but they don't provide a lot of metadata. And we basically have already this data here, and we have other cases like Pride that contain a lot of metadata. And as Henning said, the system is able to find those ones that provide more metadata, but the XML already, you know, because the way that we design the system is the XML provide a way of plugging both databases, and only the system will show you the data sets that contain more metadata, let's say.
That is actually one of the sort of little tricks we hope to employ. The better the metadata and the richer the metadata you provide as a data source, the more visible you will become in the indexing.
Yeah.
And then do you envision any way to have that principle on a sort of individual record basis? So for example, suppose I, as a data provider, can provide more data than is parsed in the, the PRIDE XML formatter, right? And I can now go add additional tags or something like that. Any thoughts about how individual records can be enhanced?
I think this will be, well, two things. So first of all, I would say that's probably beyond what we want to do and definitely beyond what we are funded for. So I don't think we want to play with that in detail. The other part is, as you're aware, we have the request for an administrative supplement pending. And if that goes through, then the part which will be done by, well, somewhere between UCSD and Oxford, I hope will be to take this XML, run it through some kind of, let's say, ontologically aware machinery and spit back an enhanced XML, which then will make the overall index cleaner and better. That would at least be my ideal vision.
Makes sense. One last thought, and then I'll be quiet. As you're talking, it reminds me a little bit of the Bioportal Resource Index. And I think they might think that they are, would have been an early precursor of this, right? So they took, what do I see here? I think they have Geo. I don't see any proteomics stuff, but they have dbGaP, they have PubMed, they have NIH Reporter, and then they run it through a very, very simple, concept recognition suite. And so you could then go there and, you search for breast cancer and says, okay, well, 3 records over here, 10 records over here, so on and so forth. Have you guys looked at this at all?
No, at least I haven't. I don't know if Yasset or Mingze have, but I haven't looked at that. But we definitely don't claim to be the very first to do this. It's just that we did it specifically for omics, and I think we did a good job.
I'll just forward you the link. I mean, I think there's, anyway, I'll forward the link just as an FYI.
Yeah.
Okay, any other questions? Okay. Well, then, thank you, Yasset, for the presentation and initiating great discussions. That concludes our presentation today. So thank you, everyone, for attending today's conference.
Thank you.
Yeah, thank you.